Okay, it's September 24th, and we're here with Walt Gurnick, a journeyman foreman. Is that correct, Walt? What's your actual title?
That's correct.
Okay. And
I'm actually a journeyman wireman,
I
and
see.
I'm in a foreman status.
Are you a member of a union?
Yeah, I'm a member of the MBW,
And what does that stand for?
International Brotherhood of Electrical Workers.
And how
Local
long
441.
how long have you been in that union?
20 years.
And over the course of the 20 years that you've been held this job, what kind of experience do you have? For example, how many years have you been a foreman, first of all?
Okay. Actually, I started in 1974. 1978, I graduated and became a journeyman electrician. After I graduated in 78, about 1980, 2 years after, I started running full-time foreman work. And ever since 1980, I've been in that status. I've been with one contractor for 20 years, which is a little unusual.
Who is that?
Enterprise Electric.
In your capacity as a foreman, are one of your jobs to see that safe electrical power is provided at different job sites?
Yeah, and well, basically I've just been in one job site. So it's a pretty large facility, and we hold regular training and safety meetings, and most of the personnel I work with are well trained or actually have more years of experience than I have.
Are you familiar with the Marine Co. NCAP and the Hubble NCAP that was involved in this case?
As far as the Marinco, this is the first time I've ever seen them, but as far as the Hubble, we use them all the time.
Okay. Can you describe for us or tell us the major differences between the two?
Well, just off initial inspection, you have the external strain relief on this one. And probably if we take it apart, there's probably an internal one. And it looks to me like on this particular cord cap, you have a little bit of more surface area contact for your ground area connection.
Is there any safety considerations when you have a strain relief device on the outside as Hubble does, and apparently on this Marine Co. NCAP, the
No,
strain relief device is on the inside?
if everything's properly done, I would imagine that they both offer this, a safe amount of the external jacket grip connection to warrant a good connection.
Could you, I guess what would be really good to start, could you just sort of can you take apart that end cap and just explain to us how it's wired up?
Okay.
That would be the first thing that we'd really like to know, is start from the actual, what we've got here, and we've taken many depositions on the case
Okay.
from different people, but I'm still unclear about exactly how this thing gets started from the very beginning. Like the wiring of the thing, who does that?
Okay.
And if you could, while you're doing that, if you could identify both whatever name it should be called on the different parts, and then any other names that you've heard other persons call different parts, because oftentimes we'll have several electricians calling what we think might be the same part several different
Okay.
names.
Well, first of all, to clarify, things from the live end of any source, it should always be a female type connector, which would have an open end, and I usually refer to it as the female or male. Some call it a cap and body. That can get a little confusing in the field if you're not clarifying yourself. Usually the cap is the male and the body's the female. I'm even confusing myself, to be honest with you right now.
So is this a male then?
This is a female.
This is a female, okay.
And this should always be to the live end of the connection. And the reason being is you don't have any male ends. These are all female cord caps. these would always be your live end of your circuit. The reason being, you would never have a live circuit with hot male prongs sticking out. So that's basically the basic safety start point from a cord cap or female-male arrangement. The female end is always the unexposed live end. So you're energized. This would be your hot part sticking out of your panel with a circuit breaker behind it.
So the female is
Is always
female
the
end is
energized.
always the energized, the
That's
part
correct.
that's the hot part.
Right.
So in our particular case then, just from what you've heard, that means that Mr. Pena had the male part which wasn't energized.
Which would have been the non-energized part. He was plugging into probably the energized female part, probably provided by another
Okay.
contractor.
So let's assume now that what I'd like to do is show us, let's assume that, okay, you get a call, you're on the job site, you get a call that what we need is we need a pigtail put together
Right.
and connected to a temporary power cord, as Berg did in this case. But I want to go back to the very beginning. How does that product get put together initially? This
Okay.
product,
First
you were
of all,
to take it
we'll
apart.
just pull it apart.
Okay.
It might be easier if we just started with the bare cord and had you wire it together before you take it apart.
Probably easier to take this apart and start.
Okay. Exactly. So what is the white part called? The white part of this device?
It's just part of the assembly. That's the insulated part of your female cord cap.
They call that a cord body? Or is that
I
something?
believe the male is the cord body. This is the cord cap.
Okay.
Have you ever heard that entire structure, the white and the yellow, been referred to as an end cap?
No, it's just
So there's really no distinction between an end
other
cap
than
or a
then
cord cap?
the best clarification is male or female.
I see.
See, I went to Green Coast factory in Northern California, and I deposed the lady that runs the factory
Right.
to see if there was any way that the collets could have not been in there when it left the factory. And they said very, very unlikely, and they showed us the whole procedure.
Yeah, that could potentially happen. That should be drawn to the attention at the time that a person wiring the thing together draws it to somebody's attention,
Right.
saying, hey, there's no strain relief on this.
Right. So we're going to be talking, but now what are you doing with the white part? You're going to be...
Okay, what I did was just unscrew the makeup part of the assembly so that you can push the area where the conductors are terminated on the cap to the point of the screw termination, which terminates your conductors. And usually they're all identified also on the instruction sheet.
by color, right?
By color or designation of screw plating. It'll either be brass or silver. And there is a color code in the industry that's pretty basic throughout.
At your job where you are a journeyman foreman, do you, from time to time, ever have to do pigtails? Or do people under your supervision have to do that?
It would be people underneath me.
All right.
I'm not called too much in my position. I used to do it.
But
I
sometime-
wouldn't make anybody do anything that I couldn't do myself.
I understand, you've done it many times,
That's correct. I've made up.
many pigtails. Before we go further, let me ask you a question.
Okay.
So if you, about this, let's say that you've put together a pigtail and you've used it at some location, and now it's time to move it to another location. Let's say the next day.
It's always best for the person doing work to check their own work and not take anybody's word for nothing, ever.
So what I'm trying to get
Yeah,
this
you
go
never-
forward, let's say that this pigtail, as you've just taken apart, but the pigtail attached to the temp power cord was on the second floor. Now Berg said they're done on the second floor,
Yeah.
and it's nighttime. Now the next day they're going to move to the third floor. We know for a fact that we think that this temporary power cord was used on the second floor with no problem. So now it's moved to the third floor.
Mhm.
And when they move it from one floor to the other, do they have to
There's.
connect
see-
it up again?
See, there's no guarantee that when they move something from the first floor to the second floor, somebody didn't grab something and now they're scrambling for a missing component.
Okay.
You know, you can't say that all the components from one position were taken apart and moved to another location without an infraction or something getting missing or something getting broken.
But let me ask you this. Let's say, though, that they actually take the object from the second floor.
They should have never had to take the cap apart. They should have never had to do that, you know, when they moved it from one panel location to the other. Because it would already been assembled. The only part they would have had to assemble back into the panel would have been the other end, which would have been stripped back, taken into a panel, and then terminated to an appropriate circuit breaker rating, which in this case would have been a 2-pole 50-amp breaker.
So you're saying that in this particular case, there would be no safety reason or any other reason when they switched floors to check to make sure the collets were there? That's what we're trying to understand.
Yeah, I don't believe if it was made up and it was sound in one piece, and they might take a visual inspection to see if any damage was done, but there would have been no reason to take it apart after it was assembled.
Is it true that if the collets are missing, though, and you're going to carry this thing, that you should be able to know because it will be loose?
Well, what happens is if the collets are missing, now you're going into the electrical termination end to keep the integrity of your connection. The collets are there to keep the strain from getting to the termination, your electrical connection.
I understand, but let's say hypothetically, the collets were there on the second floor, and now we're moving to the third floor. So when he disconnects, whatever he disconnects, and then he lifts up the thing, would you be able to tell that the collets are no longer there?
No, you wouldn't be able to tell because they'd be underneath this cap.
And it wouldn't make it looser or anything?
Well, you know, like I'm saying, if the wrong size cord was used, those collets would have been missing from day one
And it's
when
very,
they assembled the pigtail to begin with.
is it,
And it's possible that they could have used that cord on the second floor and never had an occurrence. But
How
when
is-
they moved it and some other personnel went to plug into it, maybe he used a different procedure. Maybe he skipped something. Maybe he didn't go to the breaker panel and shut it off, check that it was dead, plug his connection together, and then go re-energize it.
well, let me ask you that before you go further. In this particular case, the foreman for Berg said the following. He said, for the purpose of safety, on the first two phases of the job, they would put together these pigtails, and once it was all ready, they would turn off the power at the power panel. But during the first two phases, the subcontractors were getting upset because it was taking too long to, once they hook up, then it was taking too long to find a Berg employee. So what the foreman did, he says, oh, then let's just leave the power on. Now, in your experience and training, is that a dangerous thing to do? And if so, why?
I guess if everything was true and sound, it wouldn't be dangerous to leave the power on.
But in this case, it seems that because it wasn't...
But it's just not good, safe practice to be plugging this size of a cord connection into a live circuit. Because you just stand the potential of it just endangers safety. Even though the thing's rated for it, I wouldn't recommend it.
So it's, would you say it would amount to negligence? For
If
them
the
to-
collets were missing, yes, it's negligence.
Oh, yeah, right. We're going to get to that in a second. Okay, so why don't we go back to...
The cords are designed, if they're properly done, to plug and unplug from a live circuit, if everything is sound. It's up to the party that's doing that, or the responsible party, or the worker, to check polarities and to make sure that everything's sound, because you don't know if somebody's miswired something either.
Okay, so let me ask you this.
Yeah.
Before you go to doing that. Some of the testimony has been that in the majority of cases, Berg would purchase the entire temp power cord
Right.
pre-assembled by some middle company,
Okay.
and that then they would store it in their warehouse,
Right.
and then when it was time to put in operation, they would put it in operation. Now my question is, let's assume that's you, now you're Berg,
Mhm.
The company has purchased a temp power cord that was assembled by another company. It's in their warehouse.
May I interject, Paul? Because I'm not sure. I just like to find out if a temporary power cord and a pigtail are two distinct things or if they're the same thing.
I think, correct me if I'm wrong, isn't this the temp power cord, the black thing?
Temp power cord would be any length of this.
Right, okay. And isn't it true that you can buy
you-
from certain companies,
You can buy them
just
pre-made.
like this, pre-made just like
That's
this?
correct.
And in some cases, Berg did that, they said. In other cases, they just bought the end cap, I'm talking about the CS6364 in a box,
Mhm.
and they would have their employees do the temp power cord.
Right.
But they're trying to say that in this case, and they're trying to say it to minimize their liability, they're trying to say that in this case, they had no obligation to check to see if the collets were there because they bought the temporary power cord pre-assembled, it stayed in their warehouse, they used it, and they had no obligation to check if the collets were there. And I'd like you to address that. That means before you put, is there any law or any rule that says before you put a temporary power cord in operation, you have an obligation to check to make sure it's safe?
I just think it would be good, safe practice for the safety of your personnel to always check.
Okay, well, how would one
At
check?
point, huh?
Let's assume that we know what happened. in
Every
this
time
case.
you disassemble it and reassemble it, you would probably want to check.
Check to see if the collets were there?
No, just check to make sure that the continuity of the system is there. To make sure that the cord cap, isn't been ripped, pulled, to see if it's been injured from stress. You don't know what the thing's experienced.
Now, when you say every time you assemble and disassemble it, do you mean like in this case, go from the second floor to the third floor?
That's correct.
Right.
You don't know what's gone on
Okay, but
on
time
that
out.
floor.
What I'm asking you is, assuming the collets were missing, in this particular case, you say that it is do you think it's negligence for them not to check to make sure that everything's safe before they put it back in service?
Yeah, I would say that everything, if you moved it from one location to another,
You should
you would
check.
have to check to make sure that these assemblies were sound and
Now,
secure.
How would you
There's
go
no-
about doing it?
There's no way to check, and it's just a visual inspection. If,
You wouldn't feel there was a need to unscrew that cap?
you wouldn't feel there would be a need to unscrew that cap. There could be hidden danger in there.
Wait, so you're saying that,
I see what you're getting at. Potentially there could be hidden danger, but by looking at this, if I looked at this, just from my experience, I would say that there has been no injury to this cable. Just by judging that, just the way it's crimped down and the way it's bit. This one has an external, and you can see it.
now let's talk about,
That's probably one of the advantages, and I can see why you're bringing that up, because you can actually see that this is actually biting the cable.
one of our experts has in fact said that it's
And
safer
in this
to do
case, you
can't see.
cannot see,
Right.
because it's assembled, you don't know what's in there, and that's why I brought up the thing that's saying that this one visible, that there's
So-
hidden danger in there.
3 months
So-
after this accident, 3 months after this accident, Marinco discontinued making this product and went to a strain relief system on the outside. Now that could be a coincidence, but other
That may
experts
be a
we've talked to.
coincidence, or they may have had enough experience in the field, and that's, the only reason I'm saying this is only through experience. Somebody's using a larger cord, this is a, I think a 6/4 cord, if I'm not mistaken. This is a 6/4 conductor cable, which means that it's number 6, 4 conductor. There's four conductors of number 6. If they use 4 conductors of number 4 cable, it's a little bit fatter, it's the next amperage rating up, which might be 60 amp. And if they try to put it in there, these collets, somebody's going to break those out of there.
We don't know,
Because you
What
don't have the
size?
tail, right?
right, and we haven't even asked in interrogatories that question. We need to ask that.
That's a potential reason for the collets to be removed.
We could depose the company, as you said, and get that answer, because we have already deposed them. Let me ask you a question. We can just take out the collets by snapping them out, right?
Now, let me,
Because I wanted you to do that for a second. You just push them down. We looked at these things with a little force. They'll come out.
okay.
Why don't you take out the other one too? No, let's.
I don't know, ask this company if they offer different size collets for a larger cable.
That'd be good to know.
they may come with.
See, I just snap it down. Can you, you snap it? No, I don't pull it out. I snap it down. Let me show you.
Oh,
Yeah.
just like that.
And why don't you do a test? Why don't you now put it back without the collets? And put it back without the collets. And I
Yeah,
guess.
that offers no.
Wait a second. Okay, go on.
Yeah, you won't get any. What it's designed for, and I'll just show you on this tape after you screw the collar down.
Now, would the collar have the same amount of torque on it that it would if it was screwed onto
See,
a clamp?
it just slips on the cable.
Well,
What happens is then you put the strain relief on your electrical connection at the termination on the screw.
Time out. You mean to say that without the collets or with the collets, there would be absolutely no difference when someone lifts it up in terms of whether it would move around or not?
With the collets on, you won't stress the electrical connection.
You know, it's like so difficult. It's like going to law school. I'm trying to understand. What I'm trying to understand is, let's assume that everything else was fine. You mean this thing was put back together, but just the collets are missing.
Just the collets are missing. You're putting the stress of yanking on this onto your electrical termination.
Right. So now the collets are missing. I'm moving it from the second floor to the third floor. I lift it up.
Mhm.
Am I going to be able to, will it move more easily? Is there
No,
any way I'm
no,
going to be
it'll
able
all
to
be
know?
secure. You won't know anything.
So I won't know anything. There'd be
You
no way
won't,
of knowing.
you won't know. The only thing is that if the collets were missing, and this is really a visual inspection, this threaded collar will not butt all the way down. And I mean, nobody's going to look at that. But you're not going to be able to tell that the collets are missing when this thing is threaded all down and it's moved from one floor to the other, because this thing's going to move around just like it would normally.
Let's talk about this. If in fact the collets, in your training and experience, do you learn that you better never use one of these temporary power cord and end cap deals or pigtails unless the collets are there? I mean, is that something you just learn?
Yeah, it's in my training that you always secure the cable so that the strain relief isn't dependent on the electrical connection.
The answer is that it would definitely be gross negligence not to make sure that this thing had collets or another strain relief device before you put it in
Yeah,
operation.
because you don't want to yank on the electrical termination.
So let's go back. So now I said to you that let's say Berg is telling the truth, and they purchased this just like you see it as part of a 10 power cord. Is it not incumbent upon them before they put it into power, to at least before they put it into the job, to check to make sure the collets are there?
Yeah, I would say that regardless of what they purchased, if they're installing something for somebody else to use,
Right.
it's their liability to make sure that everything is sound.
And how long would it take to check?
Less than 5 minutes.
Okay.
All you'd have to do is unscrew the end of the collet.
Well, I'm just
And
thinking.
then the next step is you energize the circuit and you check to make sure that the polarity of the makeup is correct.
Okay, but maybe I misunderstand and I don't understand. Why wouldn't it take 5 seconds? Not 5 minutes.
Well, I'm just calling 5 minutes.
I know, I
just
just want
for
to
a
be clear if
comfortable
I'm
time
missing
frame.
something. Isn't it true all they'd have to do, it's in the factory, they're about to take it, don't they just have to unscrew the black lid
That's
and look?
correct.
So it's literally a couple
I
seconds.
mean, if I was doing it, I'd take it even a step further, take it apart and make sure that the terminations are tight, because a lot of factory stuff isn't tight on the electrical termination. Then you end up with a hot circuit, you end up with a burn, you end up with a fire problem.
Okay, now
I
we're
mean,
back.
that's just me
Would
personally
any electrician
speaking.
know that they come from
I
the
wouldn't
factory?
say any. I would say that a properly trained person would go through a whole checkout. And that's not even to say that a properly trained person can get a little complacent. They have to be reminded from time to time. That's also true. That's what training or safety meetings is all about. You're supposed to review these things every once in a while.
What do you guys follow any kind of codes or rules or regulations? Like, I have a copy of the National Electrical Code. Is that
That's
part of your
that's
training?
yeah. That's basically like a national Bible. The jurisdiction you work under can be more stringent than the code.
But
In
they
other
would
words,
have to follow at least those minimum
that's
requirements.
a minimum requirement.
And so if it said in here to inspect the receptacles of all temporary power prior to using a
Energizing.
construction site, what does it mean, inspect the receptacles? How would you do that?
well, it depends on how far. You can be lenient or you can be extreme.
What is a receptacle? What part are they talking about?
Well, any of these are a receptacle.
So when they
Or
say
the
that,
10 power boxes that you're taking these cords, you're taking a power panel
So
out.
how would you test it for continuity to make sure it's electrically continuous? Would you have to take it apart?
What you want to do when you check for continuity, say you just made up a cord, what you want to do is check for continuity. You make sure that the green wire here goes to this. I want to make sure I'm right here. This center pin and the side brass
How
here.
would you make sure that that happens?
You have to use a meter. You have to use a continuity meter.
So would you have to take this apart, or would you do
No,
it right on?
no,
the-
you just take a probe and you stick it here and you stick it here. You should have continuity there. Then you take it, your meter, and you keep it on here, and you go from phase to neutral. And if you got continuity there, you got a problem, because now you're cross-wired or something's touching that shouldn't be. Then you should take a phase conductor, which would be either your red or your black, or in case of three-phase, they'll even use the white wire as a conductor. Only because they only make the molded cords in a certain color arrangement. Sometimes you have to use the white wire as a phase conductor of current.
And how would you test for correct attachment of the equipment grounding conductor?
That would be your green.
Oh, that is the
That's
green
your
one.
green is
Okay.
your equipment grounding conductor. That's your safety ground. That keeps continuity of the whole electrical system from point to point. And that's usually your first point of check. You make sure that green goes to the right pins on the capper body, and that it does not have continuity with any other conductor.
Now that would have been done prior to them installing this in the third floor.
It should always be
Should
done.
have been done?
Yeah. I mean,
Yeah.
it's just a standard way of wiring
And
practice.
if wires
Any-
were crossed, they'd be able to tell from that test.
That's correct.
So if they'd already been pulled loose, such as in transportation
Yeah,
or
or if
something.
the thing was twisted, they'd be able to ring out and find out there was a problem. But if they had that thing energized and it was sitting there, that should have popped at that point also.
So it's
So
more likely
for it to be live, what was probably happened was when the person went to twist it, is when the occurrence happened via the collets being missing, via putting a strain on the conductors. And what I meant to say was that if these conductors are stripped back a little further and you go to roll this cable, you have the potential of rolling these conductors across each other if they're stripped back too far. That's the reason the collets are there, so you don't put a stress on this and twist these up while they're made up into their terminating points. And when you cross that up, you create a dead fault. Or you create a potential of where he could energize the casing of the cord if he's not connected at the other end to anything, where he crosses this up and he's creating a current thing through both his hands, through his chest, and whatever else have you. He gets in series with a dead short, and you end up in a very hazardous situation. It just, with the collets missing, you're putting, like I say, you're putting the stress on the electrical termination. And when it was in there, and if they were stripped back a little further, being you weren't able to see this cord, I would venture to say that it probably showed that they were back and that the collets were missing. And when he went to roll it, it just took a little bit, because these things are pretty close in here. And when he twisted it, it moved these conductors in such a fashion that they just touched. Or another bad makeup case is that these are stranded cables, and if they terminate, sometimes they'll roll up a little spider of the termination like this, and nobody sees it when they make up, and it's just sitting there, and it when it rolls again, it's just bringing the chance of those two touching that much closer, these little strands, if they're not terminated right.
Should a non-electrician try to wire one of these?
No.
So
No,
if you
even
had
even an experienced electrician, when they're terminating stuff like this, it gets a little frustrating.
So what do you think of if they were marking the damaged ones to be returned to say a facility where a bunch of non-electricians were repairing and then sending them back? Would that be appropriate, do you think?
I would venture to say that If they were trained enough in making the cables, you wouldn't have to be a qualified electrician to do these all the time if that's what they're having somebody do.
What if they're doing several different things?
It's increasing their liability by doing that.
Why? Why do you think that?
Because they have nothing to go back on. They'll say, you know, if something happened, geez, well, you had somebody non-qualified doing something, then all of a sudden the liability comes back on the person who either has the contractor license or whatever, becomes fully liable.
Have you ever heard of people using non-electricians to wire pigtails?
I've heard all kinds of stories. I mean, I've been down to Mexico and I've seen one-wire extension cords and they're using the building ground as a return. You know, it'll all work, but as far as safety, I mean, it's about as unsafe as you can get.
No, well,
Somebody with damp shoes could be killed doing something like that.
with this type of and size of cord, we're dealing with quite a large amount of electricity. Is that
And the
correct?
potential is there for quite amount of current flow on a fault.
Okay, so we're dealing with a higher quantity of a more severe.
Yeah,
Charge
the
if
50
it
amp
were
dead
done.
short fault is, I mean, coming off that side is a branch circuit. It doesn't matter. Fault currents, even on a 20 amp rated receptacle, can be real severe.
But just the sheer magnitude of the force that generally goes through
Well,
there coming
yeah,
off the fault
the
box.
bigger you get, the bigger flash, the more amperage flow you're going to have. It's all,
So that would put someone on notice that you're dealing with something that could be very ultra hazardous.
well,
Don't you think that working on a cord like this would require a little bit more attention than say just wiring up a
well, usually temp power in this kind of fashion, and I got to be honest, is it gets a lot of a physical abuse.
Mhm.
I put temp power in on a construction site one time, and the carpenter foreman rolled over this cord with a forklift carrying steel beam casings and just blew it in two. And I physically went after him and drew it to his attention, and also got back to the foreman that was providing my temp power, and it was the main cable coming in, and he had my cord fused at like 200 amps, and I jumped all over him. I mean, I drew it to their attention. I says you're oversizing the feeder coming to my cable, and I says, and furthermore, I says, these guys rolled over it, and I says, they're unsafe on the job.
Now, when you say fused at a certain amperage, is that where
Yeah,
the circuit will be broken?
Yeah, you shouldn't exceed 50 amps. That's what this cord's rated for.
Okay. So if at the accident
Now-
there was a circuit breaker that was a 50 amp circuit breaker, that means that something greater than 50 amps went through there and broke that circuit.
On dead fault, a 50 amp circuit breaker is rated to trip at 50 amps. Basically speaking, on a dead fault, it's going to trip real quick. So it's basically amount of current over time is how basically a circuit breaker trips. There's two things that trip it. There's a thermal trip, which is long term, and then there's a magnetic trip, which is short term. Magnetic being high inrush current will trip the breaker on a dead fault under short time. The thermal trip in a breaker will trip a breaker, say the 60 amps is going through this cord. Well, 60 amps can flow through this cord for a long time before it'll trip a 50 amp 2-pole breaker. And they trip at different ratings on the thermal part. That's not as critical. What you want to do is break the circuit under fault.
And you mentioned a dead fault. Is that to be distinguished
Well,
from
dead
another?
fault to me would be phase to phase or phase to ground.
Okay,
which
so with the
pro-
ground fault interrupt, are you at a dead fault situation?
No, with the ground fault interrupt, probably wasn't on the pigtail.
No, it wasn't.
He probably had the ground fault interrupter on
His
the part
hand,
he was
right.
plugging in
Okay.
downstream. That wouldn't have
Okay.
done anything for him there. Ground fault would have been downstream protecting the people at the user end where he was plugging in.
Mhm.
Would a 4-4 make a change in the amperage or the voltage? Using
No,
a bigger cord, that wouldn't have made any difference in that area.
doesn't matter. The amount of fault current on a dead fault coming out of a 50 amp breaker is a misnomer. It's up in the 10,000 amp range. That's how much current will flow in a few microseconds on a dead fault. It's way up on the scale. Whatever it has to do with the transformer that the service is connected to, and that downstream is how much.
So the only unsafe feature of the larger cord
Is
the fact that it wouldn't be able to.
that you'd have to remove the collets.
And that affects
Because
the connection.
you're actually taking a cord that's bigger than it's rated for the cord cap. you're installing.
Have you seen that happen before?
Yes,
More than once?
yes.
For that specific reason?
Mm-hmm.
And then the person can't return the collets or it won't work.
That's correct.
So,
Now
but isn't
let
that
me,
extremely dangerous?
uh,
Because you don't have the strain relief device in.
that's correct.
But what?
In some instances where I've installed temp power, we have terminated the cable in a fashion where we've done the makeup and then we support it outside of it so that the termination, and now this is just for a one-time use. I mean, we're installing it and we take it out. So my people are trained to, and I tell them, I says, sometimes we'll just terminate into a box. We won't use we'll just use the ball ends of the cable and we'll string from point to point. And we'll secure the cable so that you cannot pull on the electrical connection. If somebody gets that cable and rips it, they're going to rip it in two before they rip it from the point where we have it tied off at.
Going back to moving a pigtail for a second, when you say the scenario we discussed earlier, where we're moving from floor to floor, if you're only disconnecting from the box, you really wouldn't be concerned with the end cap itself. Is that correct?
Yeah, that should already be sound, see.
So, is there any danger in rewiring on the bare cable end to the box? Would that have any effect on the danger of the end cap?
Only from how many times it gets used.
So in other words, if you're getting
Age will start cracking the outside. Once a cord gets to that point, you just get rid of it.
if you have bare or spidered wires on the bare end side of your cable, is there any potential for that to travel all the way through to the end cap of the pigtail? Or would the problem have to be localized in the end cap itself? In other words, a problem wiring to a panel box wouldn't get as far as the end cap of the pigtail, would it?
You could set up a potential hazard by wiring the pigtail into the panel and taking the green wire to a breaker end. Now that's gross negligence for an electrician to do that, but I mean it is possible. Or taking the white wire to a circuit,
And the
even
result
though
of
it's
that would
designed
be-
for it, you're getting out of what they spell in here as calling maintaining continuity and polarity throughout the electrical system.
So
If you're varying from that, then you're setting up a potential hazard.
what I'm trying to get at, would an improper wiring at the panel box be evident on the end cap end of a pigtail? Would it travel
It
all the
would
way
be
through
evident.
before
I
it
mean,
would blow?
if they should have energized it and checked it before they turned it over to somebody to use.
How do you do that? How do you energize it and check it?
Okay, after you've
Well, we're going-
rung the cable out, like I
Right.
said before, and you
What-
check to make sure that the pigtail's sound.
Time out.
and you
This
don't-
is what you're saying they should have done before they put it in operation on each floor, or just the first floor?
Anytime they move it.
Okay, so this is what they should have done at minimum, what you're going to tell us, right?
Right.
Okay, go on.
You should wring out the cable to make sure that it hasn't experienced any unusual stress. When you go to you got to check the pigtail before you terminate it to a live circuit. You've got to wring out the continuity and make sure that your green wire, which is your system ground or electric ground, has continuity from your point of connection to either your pin and your case ground, and has nothing to do with any of the phase current carrying conductors. And then you should ring out each phase conductor to its appropriate point, and also ring out so that you're not getting anything cross-wired or phase-to-phase fault wiring. And you should just ring out each conductor to each point of connection on here and make sure that it does not interfere with any of the other conductors.
Now, I asked this a couple of times, but I'll ask it again to make sure. When you're doing that inspection and you're holding it like that,
All right.
again, no reason to suspect the collets are missing.
You can't tell if the colors are missing.
What about if the gasket is gone? The gasket was also gone.
That's basically either a minor moisture or dust-proof barrier.
The fact that it's missing should not allow you to see if the collets are missing? Okay.
Not in this case.
All right.
But now, have you ever used, just so we're
I've never
clear,
seen this type of a cord cap connector, to be honest
Have
with
you ever seen one with collets on the inside like that?
Yeah.
Oh,
Hubble
okay,
used
just
to
not
make
that particular
Hubble
one.
used to make them.
Hubble used to make them.
Mhm.
What, do you remember when they used to make
God,
them?
that's back, God, when I started, so that was early 70s. They stopped
And
it.
then they stopped.
You need to talk to someone from Hubble.
Yeah.
That's always important. Let me ask you a question. So now you've done this test. This is what I'm concerned about, or I still don't understand. And everything's cool. I'm now bringing you forth to our accident here. If someone from Berg had done exactly what you just did, would there have been any way that would have prevented the accident? Because they would have figured out what... See, I still don't understand something. Just the fact that the collets are missing.
Yeah, it's potentially that even the Berg guy handled the cable from here and held it here and checked everything and let it go. But all I'm saying is when the guy went to twist lock
Our
the
guy.
device in with the collets missing, you put a stress. I guess I could show it better if I assemble this thing and maybe give an example.
Yeah, good idea.
If I put these conductors in with the with this part missing.
Wait a second. I think we're ahead of ourselves. This thing right here. Who puts this together? Who wires this up?
Well, either the contractor on site will do it, or like you said, that somebody might have pre-wired these and they bought them that way.
Well, Marinco, when Marinco sells it, it doesn't have any wires in here, or it does.
I don't know if Marinco sold these to a place in bulk and then they made up a bunch of pigtails for somebody.
No. What I'm asking
No.
is this white thing right here.
I don't know what.
Is this right now like it comes from the factory?
That's correct.
Okay. There's no wires in it.
That's correct.
Okay. So now you buy it like this, and what do you do? What's the first thing you do?
Well, first of all, it comes all assembled. You disassemble it. First you put this on the cable. Then you put the next piece on the cable. And then you pre-strip this to the appropriate dimensions as specified in the instructions. And then you make sure all these strands are straight and sound so that you can put them in the device. Which is the part that gets real frustrating. And guys get it in a hurry and they're under pressure. And it's all spelled out.
Color coded.
It's color coded. But the green goes here, the red goes here, the black goes here, and the white goes here. The white's always identified. It's the silver screw on any cord cap. The ground is specified as green on any cord cap. The phase conductors, not necessarily so. They may be either color coded or they're also labeled X and Y and Z. Ground is usually labeled G or GR, and white is, of course, W.
How do you know how tight to tighten those? I assume you're
Well,
going to tighten them in.
yeah, there's a specific, probably a torque spec in here, but
Actually,
you want
there's
to get
not.
it.
That's why I'm
Yeah,
asking.
you want to get it as tight as you can.
As tight as you can, basically.
Right. Now, in this particular case, if you would have stripped the cord properly, there's a female end of the conductor of a cable and a male end of the conductor of the cable, and I'm noticing here it's backwards. The only reason I'm bringing it up. If this is the end that should go into this cable, and the only reason is it all lines up, the green would go in the green, the black would go in the black, the red would go in the red, and the white would go in the white if this end was stripped. This is backwards. It still doesn't make any difference because all you're crossing is the two phase conductors. But if you're keeping integrity and polarity on a system, you would bring that to the person putting these together. So that, and this is the part that gets real tricky. That's why these are tapered. These have to go in here, and you don't want the conductors to stray back like they're doing. Here, they stripped conductors into the cap body here, and gone around, and I've tightened each one of these terminations individually. And what you always want to do is wiggle a little bit, because the strands give way sometimes and you get a little bit more tightness on it. But you want to get it as tight as you can possibly make it without cross-threading the termination or cross-threading the screw in there.
Now, when you say
And that
wiggling,
usually can take just about as much as somebody can.
when you wiggle it, you would be able to tell if there were loose connections in there?
Yeah, you want to wiggle it because the conductors move in there a little bit, and you can actually get a little bit more tightness on your connection.
So if you're wiggling it and you get a lot of resistance, you'd know you had a solid ground in each one of those terminals.
Well, you want each connection to be as tight as possible. And they're coming out more stringent on their requirements in the future, that those things are supposed to be torqued with an inch-pound wrench
So there's actually,
or a foot-pound wrench.
there would actually be a specific setting
That's
to turn
correct.
each one of those terminal screws.
And that would only be to give you the maximum amount of tension without cross-threading or cross-stripping the screw,
which would damage the
which would
lines.
damage it for good.
When does that come into existence, that
Uh,
regulation?
That regulation, actually, item number 8 here in Marinko's spec here says that tighten all terminal screws 22 to 25 inch-pounds of torque.
Is that a Marinko
Yeah.
that you're looking at?
Mhm.
Okay.
It's coming out on everything. They never used to have that before, but it's coming out more so and more so, and that's because they're finding a lot of these are burned up, and they're coming up with a spec for tightness. So
There's
basically everybody's toolbox is going to have an inch-pound torque wrench in it, and also a foot-pound torque wrench for bigger connections.
There's nothing in the instructions that you think are in any way inadequate. Explain how to put this together.
No.
My only question would be, how would you know how tight to put on this black piece?
Um,
How you know, you hand
Okay.
tighten it, how do you know it's tight enough?
It's Satan here. It says here, like item number 11. It says tighten end cap on main housing to engage strain relief. Make sure that collets engage on outer jacket of cord. Do not tighten strain relief system down on individual conductors.
Yeah, I don't understand what that means. Maybe you could explain.
Do not
Wouldn't
tighten
that
strain
suggest that
relief
if you're-
system down on individual conductors.
If you had stripped
Oh,
back your
okay.
cord cover far enough,
No, what they're saying is if you used raw cable and brought it into here without
cover.
any cord, that they're just saying don't tighten it down on individual conductors.
Do you think that instruction should say how tight the black piece should be on it? Because it doesn't give a torque like it did for the screws, or a resistance, or anything along those lines.
From your personal knowledge, I mean, you would
You
do
want to
that
make
more
it
than
as
hand
tight as you want to make it as tight as possible.
Would you need to use
You
instrument?
wouldn't. No, you wouldn't need to use
Just
an
with your
instrument.
hand.
Just hand tight, as tight as possible.
So hopefully you're
Should
fairly
be
strong
sufficient.
grip.
Yeah, most electricians get a grip in the industry.
Have you ever heard of any electrical accidents that when you heard about them or were involved in them, where it was determined that in those accidents the collets were missing? Or is this the first accident you ever recall?
This is the first accident that I've personally been involved with. I've seen other accidents occur through negligence of the way people take care of their tools,
Mhm.
through the same reasons that this accident occurred.
Well, why did this accident occur? And what we
Um,
told you, what do you perceive?
What I'm perceiving to see is that because they didn't give you the pigtail, what I've just done is just terminated these screws in here. Now there's one of two things that could have happened. With the collets missing, this particular cable casing could have been stripped back a little bit further. The copper conductor might have been exposed another inch or another quarter of an inch, and some of the fine strands on the makeup of the cable could have been exposed. When the person went to plug this thing in, he gripped it like this, and he plugged his other thing in, and he went to twist it. And what you're doing when you're twisting it is when he went to make those connections, you're twisting these conductors just a little bit close because you don't have this collet gripping it and turning it all as a unit. You're exposing this cap head to where the conductors are rolling into each other. And what probably happened was that it ended up faulting. He ended up getting a fault current. If he had his hand on here with the metal part of the casing, there was an ionization of gas. The fault current, his hand was probably sweaty and his feet could have been wet, and if he was thrown from the point of where he was at, he experienced a dead fault through his own body.
Which is an electric current?
Which is an electric shock, voltage and current.
Now, why would this accident not have happened if the collets were there?
If the collets were in place, you would have locked, and you can't see this occur inside, but what happens is it keeps the integrity of the system so that when you turn this white part, it also turns the cable. It twists it together as a unit. But with those collets missing, you're twisting the cables to a potential point of faulting together if it's improperly stripped, or if, like I showed you before, the fine strands are hanging out from someone not taking care on terminating.
Okay.
So collets actually prevent each individual cable from crossing each other.
Well,
as
it
well
keeps
as-
the integrity of the twist lock design of the cord cap, and it relieves the strain to the electrical termination. It puts the strain on the mechanical part of the jacketed cable to move with the face of this thing as a unit assembly.
And
You cannot twist those conductors internally here with that cord grip or the collets biting on the jacket cable as a unit. It won't. You can't twist it. It's impossible. It twists the whole cable as an assembly. When you have the collets missing, you're now exposing the conductors to stress and to turn independent of the jacketed housing.
So that means that
So there's
each individual cable could actually cross.
That's correct, and then there's other factors here. It's how one of these could have been loose. One of the conductors could have popped out, and when he went back and it faulted. There's too many variables with the collets missing.
And you think the collets were purposely taken off to put a fatter cord? That seems to be your best guess.
That seems to be my thing. And then with the fatter cord, you have a tendency to end up with more strands poking out because the conductor itself is a little bigger, doesn't fit in the design tapered holes that it goes into.
What do you call the fatter cord, 4x4?
Well, the fatter cord would be one size up, which would be 4 conductor number 4.
4 conductor number 4. So if we wanted to find out if Berg had such cord that they used on a regular basis, we would ask for a 4. What would we ask
Is it
for?
4/4, 4-4, or how do we phrase it?
Now, it's usually rated as, I think, the number of conductors and then the size of the conductor.
So is it called 4-4?
It's like a
Okay, now they give the size of the conductor first and then the number of conductors. So this is actually a 6/4 cord. It's
When you
actually,
say 6/4, do you mean like this with this slash in between?
Yeah.
4/4
or
6/4?
6-4. What
Okay.
that would be this one here is 6/4, 6-4, which means it's number 6 and it's 4 conductor.
Is there also 5-4?
There's 5-4, there's 8-4.
But the 4, the lower the first number, it means the thicker it is.
The lower the first number is the size of your physical individual conductor in the cable. The next number is the number of same conductors grouped in the cable housing.
Well, a 4/4 is thicker than a 6/4.
That's correct,
So I
because
assume
it's the next size up conductor, which would be you go from 6, then you go to number 4.
Okay.
That has a tendency for a person, if he's terminating it, which possibly could be terminated in this cord cap, but you would never crimp down with the collets in place.
Okay. But this end cap calls for using a 6/4, because a 4 is too thick, right?
Which would tend for you to strip the casing back a little
And you
further.
can't get the
And you may
collets now.
strip the conductors back a little
I
further.
mean, so if you were to put one of these together, or if one of your employees were to say, okay, I need to put one of these 10 paracords together to this Marineco product, and they would ask you, what kind of cord should I use? You'd say a 6/4.
You'd have to use
And if
this.
they said, well, we don't have any 6/4, can I use a 4/4? You'd say, no way.
No.
Because,
Then you're violating the size.
does that say what size to use?
It says it at the top, I believe.
It gives a diameter reading. So,
It gives a wire range.
And does that tell you what kind of cord to use?
Well, it just gives the overall diameter of the outside cable. It gives you the collet protective range. It gives you 0.680 to 1.25. And that's just because it's designed for variable at different manufacturers because of all the different types of 6/4 cord made.
so those are actually, the numbers that you just read are inches. of
That's right.
that-
They're
that-
fractions of an inch,
that the
and
cord body can
it's
receive.
built to handle. You might even you might even be able to use a 3-conductor for a specific application.
Okay, so
But
that-
you would never use this to alleviate an electrical system without the ground. You may not need the neutral.
the size given then isn't exclusive for a 6/4 cord. It could be a different conductor number cord with the same.
Yeah,
diameter.
they're just saying that you always want to match your electrical system with what you're doing. You don't want to deviate and put
Well, if
an
that-
oversized cord in an undersized capper body, or too small a cord for a 50 amp capper body. You're just violating. Things are designed to be matched up with a specific purpose.
Mhm.
And if you deviate from that, then you're getting out of the safety factor range, and you're actually becoming unsafe if you're going and trying to make do, so to speak, with.
So you would never let anybody use that
No.
size cord with this type
No.
of cap?
No, if I was using a different cord and I didn't have the right cord cap, I wouldn't even use the cord cap.
Now, is a
I
cord?
wouldn't even waste the time doing it. I'd go.
So you'd order it or something?
Well, I'd go to a junction box and make my termination. You know,
So-
I'd go
so
to
they
some.
had an
I'd go to some other means of providing. No, I wouldn't say that they had another option. Yeah, they only had one option with this, with a 50 amp cord, and that's to use a 4-wire 6/4 cord to a 2-pole 50 amp breaker, and that's it.
Okay.
Otherwise, they should have taken power direct to a panel to the first box and not even had a pigtail hanging out of the panel.
So the alternative was to say, what would, I'm not sure what I mean, what you mean when you say into a box. You mean like
A spider
actual
box.
Plug-ins?
Well, actually, it's like a distribution box, because the 10 power goes out to something. I mean, the 50 amp power goes out to a box on the floor, and it has your GFI outlets in it, and that's usually where you distribute power in 10
So
power.
you'd have multiple plug-ins at some point?
Yeah, this would be your main feeder cable.
I see.
And then you go in, this would end up with your male part, well, your female part, because you'd have a hot end. You'd end up going into a distribution assembly out on the floor.
It'd be like a power strip where you have multiple outlets that you
Yeah,
can plug
it'd
in.
be
They could have just done that directly without the use of this?
No,
So I'm not
no,
sure.
what I'm saying is they could have gone direct from that distribution box with a pigtail right into the panel, a long pigtail, rather than just having a short one. In other words, what your person could have done if this was unsafe was take his end cap off and go direct to the breaker, to his point of connection, and not even ever plugged into the pigtail.
Well, I see what the person that got injured could have done if he was an electrician.
I don't know.
Yeah, he wasn't an electrician.
Okay,
But an electrician could have done that if they were
that's
wiring it
correct.
for him.
Yeah.
I see.
Do you know from your experience whether an end cap or a cord body such as what we're speaking of right now, does it cost more to get one that would fit a 4/4? I know they're different sizes. Does it get more expensive with the increase in the cord diameter, or is it just less common to encounter that size cord?
No, I would say that the number 6/4 conductor cord is probably pretty common for 10 power routing around a building.
So would it be unusual to use a larger a larger size cord for that type of use?
Yeah, it would be a misuse. You wouldn't do that.
Previously, I guess you would assume the person that had been injured was an electrician. Would it change your answer? You had said earlier that it wouldn't matter whether the power was on or off when he went to plug into it. Would it change your opinion to have a live one to hook up into if you knew it was going to be non-electricians hooking into it?
Through all the years of experience I've had, it's always best to give somebody something in an unenergized state until an electrician comes to turn it on.
So that's what I asked you before. It seems that this accident would not have happened were the power off.
That's correct.
It wouldn't have happened at least for two reasons. If
But-
the collets were there,
But the problem is, it could have happened at the tail end of it instead of the beginning.
So the guy used
Because
a tool.
at the time they would have came to disconnect it, the accident could have still occurred.
okay, could have, but
Could have. You would never
it
know that.
definitely wouldn't have occurred the way it did occur.
I can't say that because the accident occurred by the twisting.
No, but if the power was off when you did the twisting, he obviously wouldn't have got electrocuted.
No.
So now he turns on the power, it's connected, he wouldn't have been zapped.
You would have seen
That's
an
correct.
explosion maybe.
So
but
I'm
now-
saying,
now
you think
if
most
it-
electricians would say that Berg Electric was negligent for either A, not checking to make sure the collets were there, and or B, not having the power off at time of connection. And if so, why do you feel that way or not?
I think it would have been probably the safest way to do this is to have left the power off and been called to come to energize something. Because if it had faulted on an unenergized state, when they went to energize it, they would have noticed the fault, and then they would have looked for the problem.
How about at your place where you work?
In our place where we work, we never energize anything on a new installation or a retrofit until we have the person or operator there present to request it.
So what does that mean in English? Do we understand?
In English, in other words, they call us to turn on power to a piece of equipment
And
or
that's
to energize
because
it.
you believe that's standard in the industry?
That's probably just the safest way to protect both ends of the fence.
I understand. So what I'm saying is, do you think that if you were called as an expert, you could say that Berg was negligent in having the power on to allow someone with no electrical experience? See, because the Barsodi people...
They wouldn't be negligent if they would have checked. I don't know if they checked. I don't know what happened. I would say that they would be negligent if they just put something in and turned it on and walked away without checking it.
Okay, this is what I understand. I guess still to this day. We know collets are missing.
Okay.
Let's assume this is your job site.
Okay.
Let's assume you are the electrician. How do you avoid this accident? When you take this from the second floor to the third floor, how do you avoid the accident?
For the collets to be missing, they had to be missing on the first floor as well as the transport to the second floor. They had to be missing from day one.
Okay, now let's assume you're right, and let's assume that your theory is correct, and you're taking this from the second floor to the third floor, but you didn't install it initially. It's another electrician.
Sure.
And now you go, and wouldn't you immediately have seen, wait a second, this is not the proper cord for this end cap.
If it was improper, yes.
You would have seen it right
Yeah.
away. You'd have seen this cord is too thick, right?
You should have drawn it to the foreman's attention
Okay.
that something was wrong. And I'm going to go ahead and finish assembling this thing the whole way, but I just want to reiterate at what's happening when you don't have those collets in place. Is that understood? You're putting the strain on the electrical connection. If that wasn't there to begin with, it might have worked for a while, even on the first floor, but it just got a little bit looser over use.
Right.
When they finally got it to the second floor, it's been working for a while. Somebody just assumed that, hey, this was working down there, we put it up on the second floor, everything's fine. It wasn't checked. It just so happened that it finally got its calling, that it got to the point where without the collets being there, these conductors got worked loose. One could have popped out, or they could have got twisted together.
Sure. Let's just take these out, though. Can we just...
The other
You
cord
want me to take
has
them out
it
again?
missing.
Yeah, I want you to, because now let's do it like it really was.
The pigtail to your immediate left, the
Yeah.
other Marinko doesn't have collets in it. I
Oh.
don't know if it's any different.
Yeah, you can tell.
Now, how can you
Just by
tell
feeling
without?
it?
Yeah, I can tell that there's no collets in there.
So an electrician would have seen that without ever
That's
having
what I've been
to take it
asking
apart.
you. I remember I said, how would you know?
Well,
You said you wouldn't know, but I said,
I'm just learning. If I would have walked up
He hasn't
there,
been using this
I
part.
haven't been using this enough, but I'm starting to, you know, you can feel that there's no collets in there.
You would know that if you had never even known that there
Yeah,
was.
something's wrong with this.
Okay, so let's go back.
Is that because it's rattling, or you can feel extra play inside the body?
Well, yeah, you
So
can feel
any
it.
electrician
it's not,
holding that
it's
would
not
know.
moving with
Well,
the thing.
compare the two. Now you have one here that where the
Yeah, let's
collets
fix
are.
that one up. Let's
Why don't you
finish
fix
this
that one
up.
up and then we can.
Okay.
Well, from a visual standpoint, if you had like a 4/4 cord going into that same cord body, you wouldn't even need to check the end cap to know there was something wrong. Is that correct?
This is easy.
If you would have read the cable in 4/4 and if you know your ratings,
Well, is a diameter? I mean, can you look at a
Physical
4/4 and look at a 6/4,
of the same rating cable, yes.
and they'd be
and
two
that-
different sizes? Is that
Because
correct?
a 6/4 SO and a 6/4 of some other rating could be almost, or a 4/4 of another rating could almost be the physical same size.
Okay.
It's just that your mechanical shell is a little bit
Okay.
thinner.
Well, Paul, I think we give one of each of these to the jury. I mean, that's quite a bit different than, because I had been playing with this one before.
But I just want to stress the fact that with the collets missing, you're putting the stress on the electrical connection. And if that is continued to done that way, then what you end up doing is loosening to the point where you'll pull that conductor right out of the connection under those conditions underneath that cap, and it'll explode on you.
Now, minimum, now that you've done this, and you now see what we're talking about,
Yeah.
when the person
Now I'm
takes.
tightening this by hand.
Right, when the person
And I'm
takes the.
taking it to the point where I can feel it clicking in. And now I want to show you that it does keep the integrity of the,
So it twists
that's
the
not
entire
very
cord.
good. It's got a little bit better strength, but this is blatantly
So it's not
loose.
as much strength as a Hubble then.
No,
So it is turning a little bit anyways.
yeah.
But is there a clear difference between
There
the
is
one
a-
without the collets?
There's a
and one?
clear difference. I can turn this real easy, and what
Okay.
that's doing is twisting the conductors.
Would it tell any electrician, any competent electrician who twisted this one, would immediately know something was wrong?
Anybody competent with the liability of installing that for somebody else's use
Would know that this
would
is
know that
definitely
it's
wrong.
unsafe.
And they would
know-
feel it? Would they feel it though? Or would they just visually inspect it without ever touching it? Would they actually feel that part when they were going to install
Anybody
it?
that's aware in the electrical industry, I would feel, would know that there's something wrong with that.
What we're saying is now you've taken this from the second floor, here it is. Now
They
you're
would
about
at
to do this
least, they would
picture on
at
the third
least,
floor.
with feeling that, I would think, take it apart to say, hey, what's wrong with this? It feels a little loose.
Okay, that's what I'm asking. When the person left the second floor, and now he's gonna put it on the third floor, I don't know, how do they carry it? It's like this, what I'm doing right now? They carry it from one floor to the next, or they just drag it and carry one part?
They may just throw it
Okay, fine.
on a cart.
Fine, whatever. Now you're getting to the point that where you're about to install it on the third floor. Now, when you install it on the third floor, what do? Now you install this end cap. This gets plugged up to the temporary power, the
Well,
box, right?
yeah, basically what you would see is this would be stripped back about 18 inches.
Okay,
And you would take this into another strain relief connector in the bottom of the panel.
Right.
Usually the panel's surface mounted, or there's some way of means of getting this cable in. Then you take these conductors, and you terminate these properly at the panel.
okay. But where does this
And-
come involved?
What this is doing now is a point where the person comes up and plugs his power.
I know
into
that,
it.
but I mean, before you put it back into power on the third floor, at what point would a non-negligent electrician check this part of it to make sure it's still safe?
You should check it just like I did before you even terminating it into the panel.
So that's absolutely correct.
That's correct.
So therefore, they would be negligent.
You would
in
want
not
to
having
check
checked
the
it.
integrity, the visual integrity first, then you check, if you feel that something's amiss, you take it apart and you make sure that the electrical terminations to the cap head are sound. and you make sure that whatever's in there, why is this thing so loose?
And then you find the collets are missing on
You
it.
find the collets are missing.
So you're saying absolutely before they put this
If
in
that's
play.
the case, you should at that time replace this.
Sure. But at every floor, when they change for every floor and before the first floor, they should at minimum have checked to see if that was tight. Is that what
That's
you're saying?
correct, and just check the integrity of the use of the cable to make sure there's no physical abuse. Because you don't know what goes on. You don't know how many times this thing gets slapped around or abused or whatever.
Oh, yes. Good.
Yeah. Huge
But,
difference.
I mean, I'm not even strong.
Yeah, you can. Now what you're doing there, you're exposing the strain to the electrical termination, and that's the only thing that's holding that thing
Feel this
together.
one, Paul.
And that one's
That one's
extremely sound.
completely, I mean, that one's just
Oh,
tight.
Oh. So they were negligent then in not, at minimum, checking that, and they would have seen that the collets were missing.
If that was so the case, yes, I'd have to say so.
Now, can you think of what, playing devil's advocate, what expert that they could bring, what they would say about why they weren't negligent? What competent electrician would come into court and say they weren't negligent because of fill in the blanks? Because why under these facts?
Is it possible that they wouldn't have felt it in their hand? Or if it was that loose, would they had to have felt it?
If you really follow proper procedure, there's no excuse for not having a sound system.
Is there any
Everything,
book-
every part being there, and it being a sound connection
Is there any book?
for other people's use. That's why they usually in a construction site don't. The temporary connection is installed by an electrical contractor, maintained by an electrical contractor, and supervised by one
So,
on the site.
What
If
about
they-
asbestos removal? What if you got, all that
There's-
stuff up there and, I don't know, what
You
what
mean,
they-
you're saying that this asbestos person needed a 50 amp, 250 volt point of connection for use?
Our person was asbestos removal. So I don't know, is that not normal for them to use that much,
so here's the
Power?
deal.
It's a lot of power for somebody to use, but they use
So it might be too
exhaust
much power.
fans, they use, I don't know what all they're doing. They have a lot of,
Vacuums?
they have a lot of vacuum systems running.
so you think that might have been too much power to begin with?
No.
Oh, it would
They
be,
might have,
okay.
they might have needed
So would
that
an
much
electrician
power.
have come in there?
No, well, the electrician just provided a point of connection for the person.
Would they have been able to shut the power off so the person come in and then turn it back on even when they have all their gear set up to remove?
Yeah, it's not good policy for I guess jobs under construction or whatever, to just let anybody mess with the electrical system.
So even though they were removing asbestos, they should have taken whatever protection they needed to go in there and turn it on and off? The electrician?
I would think at best that the electrician should have shown him the breaker that fed the point of connection and instructed him to shut that off,
Before
plug
we
your
connect.
cord in, and re-energize the circuit breaker.
So they should have set up
That
some
would have
kind
been
of
the
policy.
safest policy
Seems
to
pretty
go
simple.
by, alleviating that
They
if
just
you
have to flip
couldn't,
one
if
switch?
you couldn't see,
They just have to flip one switch to turn it off?
Yeah.
Like a on-off switch on a
no,
wall?
they have to go to the breaker panel and flip the
But that's the
proper-
one that this is connected to, so
That's
5
correct.
feet away, they could have
And
just
it
turned
should
it
have
off.
been marked and designated, or it could have been tagged with a tag hanging on
Okay.
for if the person was coming in after hours. They'd just put a tag on the breaker. This
Turn
is
off
this,
first.
Yeah.
Does it add to this dilemma or this, what precautions that the electrician should have taken? If I tell you, this was at UCI, and
Yeah, UCI has
College
maintenance
students.
electricians on site that.
no, what I'm telling you is college students were walking right to and from work, right in the aisle with this electrical power thing. When I heard that, I thought that would be yet another reason why they should definitely keep the power off.
Yeah, if college students were transporting, God, I could.
I mean, I'm asking if you think that.
There, if that was the case, the cord should have been tied up and over. They shouldn't have had to ever step over it.
It was right there on the ground.
Now,
You were talking earlier that the cord should be
now
strapped.
you're creating a trip hazard for students.
Yeah, it's also on a live hot wire. That's a fact. That would,
More so a trip hazard than live hot wires. I mean, you wouldn't really get shocked by tripping over this, but
You stated before, though, I don't know if it was on tape or not, that oftentimes you attach them just to help the tension, that you strap this against the ground. Is am I mistaken?
It would be a longer tail I'm talking
Oh,
about.
if it was longer.
Yeah.
Okay.
We string ours up because we have a lot of construction personnel running around the place. We minimize the stuff laying on the ground because there's a lot of traffic. So we string ours up overhead and out of everybody's way as much as possible.
In your business, right now, like tomorrow, say, Monday, if someone that was working for you was called upon to put a pigtail into operation, would you specifically instruct them before putting it in operation to check, just like you've shown us, to check like this to make sure that it's all tight and everything else?
Yeah.
So would you instruct them to check for the collets, or would you instruct them just to, what would you say?
I think just the general knowledge of my personnel, they take the time to do that anyway, on their own.
To check as a general rule. Do you think that if we were to talk to 10 other people in your job?
You may get several different answers, I know you would.
Okay, well, that's what I mean.
Somebody may skip a step or something. I'm actually being, only because I'm aware here, I'm actually going through several steps, but it's certainly nothing that I wouldn't avoid, me personally. But when you have a human element dealing with things, humans have a tendency to forget certain steps.
If we talk to 10 people that do your job, do you think all 10 would agree that they should have the power off?
That's correct.
That's clear. That was one mistake. Would all 10 agree that they shouldn't, you're saying all 10 would not agree that before putting it in operation they should check this? Or do you think all 10 would agree they should?
You might find a percentage of error on that, only because usually some people aren't physically aware of things as some others should be.
Well,
But anytime you connect temporary power, you should always connect it de-energized and then energize it.
One
De-energize it when you take it apart.
So if you were looking at this, 10 out of 10 would put it in their hands. Is that true? Like 10 out of 10 electricians would look at the cap, put it in their hands, and visually
I would say
inspect
they
it?
would visually look at it and inspect it.
And while they're holding it in their hands,
But you don't want to forget the step of wringing it out.
but say they didn't, they would at least hold it in their hands and visually inspect it. And
I would
doing
say they
so,
would.
do you think that 10 out of 10 should have noticed it was
And
so
I'm not
loose?
saying all 10 out of 10 would draw to anybody's attention.
But 10 out of 10 would have
You'll
noticed it
start
was
dropping
loose.
on percentage. Maybe 9 out of 10 would say, they'll come up to me and say, well, there's something wrong with this thing.
But you think all 10 would have noticed
Then
it
I
was
would,
loose?
at that point, I would,
Would all 10 have noticed it was loose?
No.
How many do you
that's
think would notice it was loose?
maybe 80%, 70 or 80%.
But they should if they were actually taking a good look at it.
Yeah, if anybody's competent in what they're doing, I mean, you
So
would
those other
notice something's
20% are
wrong.
probably negligent.
Yeah.
Everything.
I mean, I had one person on my job site have something come apart on him, and it blew up. But it was after they energized it. I mean, they didn't plug up. I believe the guy plugged into a receptacle and it popped on him, but it was properly protected
How is it properly protected?
through a fuse disconnect.
Okay, so he didn't get shocked.
No.
And why didn't that help our guy in this situation?
And it just happened that a good sound piece of ours came apart over, like I say, a lot of.
Why did a fuse disconnect not work to save our guy from being electrocuted or electric shocked?
I would say it probably because of the condition of what shorted out.
What condition would that be?
In other words, the what conductor faulted to what. Either the hot touched the ground. I would say the hot went to ground. That's why
Hot goes to ground and nothing's going to stop it from...
Well, no, it's because of what he's holding on to. Did this person physically fly?
Yes, that's
did
what
he
he
fi-
says.
yeah. Then he physically got zapped. That means his feet were sweaty and...
But your guy wasn't touching that part of the connection when his
No,
thing
my
popped?
whatever popped on mine was probably just was also a phase to ground fault, but it just faulted in a fashion where nobody got hurt.
So it kind of self-contained
Right.
shock or it didn't
It's a
float
different,
outwards?
it's just a different type of connector. It's a pin and sleeve connector.
I see.
It's a little bit more stout than the regular twist lock.
Okay.
But I'm saying these things do occur. You know, you want to keep the job always as safe as possible, but there's always...
But they could have taken quite a few steps to make it safer.
That's correct. Ours physically came apart inside, and there again, there was no way, but it was just over time. And
Yours wasn't missing a collet or anything.
No.
So it had the appropriate device for strain relief, and it just kind of worked its way loose.
What happened was a conductor came apart inside when I looked at it, and it just came apart and went to ground.
And that would be something nobody could do anything about. But this somebody
No,
could.
but still, I'm saying again, it was just one of my personnel wasn't properly maybe as aware as he should have been.
Would this have been easier to spot, this particular incident we're talking about? If there was a fat cord and a loose cap, that would have been a fairly easy thing to spot.
Yeah, this doesn't even feel right, you know?
So it's easy to spot.
You're going, what's going on here, you know?
So the only way it could have been ignored, or the only way it could have gotten hooked up is if it was
integrity
ignored.
of the thing should turn with the whole cable. It should be tight. I mean, this is just like almost like spinning on there.
So you just hold it in your hand, you can tell.
It's not good at all. What that's doing again is it's working on the electrical connection. And like I say, it may work fine for a long period of time until finally one of those gets loose in there, and it just like Murphy, it caught it before somebody checked it.
So you assume this, or it sounds like you're assuming that this had been missing collets the entire time that it had been in the different levels of the building, and then it must have gone through
Different
several
collets,
people's
or
hands
somebody put an oversized cord in it.
right before installing it.
Yeah, because you're saying that this part was even missing.
Exactly.
You know,
have you ever seen a part like that missing before, one that's normally in it?
No. I'll tell them to throw the whole thing away and put a whole new one on, and not even mess with
If
it.
you had seen a gasket missing like that?
Well, not so much the gasket, but when you're saying that part was missing, somebody really tinkered with the thing. There's no reason to take that gasket off of there other than you're putting an oversized cord
That's
through
the
there.
only reason you would take that
Yeah,
off.
because
So-
he's not going to be able to make it up.
If you notice that the gasket was missing, that would put you on inquiry, or at least say, hey,
If
what's
you knew a
inside
gasket was supposed to be there.
Uh-huh.
I
And
mean,
are
not
there
everybody
normally
has all
gaskets
the
on these?
components, but somebody on the job should have been at least aware enough of what kind of product they were using.
But somebody took it off, essentially.
The
That
only
plus
reason to
the
take that,
collets.
the only reason to take that gasket off was either the thing was sold that it finally rotted off, or they physically took it off there to get a bigger cable in.
It probably didn't rot off and the collets rot off at the same time, though.
No. I'm saying you don't just rely on a gasket.
Right.
But if that was physically missing, I'm saying somebody took that off to get a bigger cable in. That's the only thing that would allude to that, because that's blocking
So
your
there's
opening.
really no other reasonable explanation other than they had to have been putting in a bigger cord.
I would say that that's probably the case. I haven't really looked inside to see how that rings in there, but that certainly blocks your assembly procedure for a bigger cord, which alludes to.
The fact that both those pieces are
Or
missing,
somebody just blatantly says, we don't need this and we don't need this.
which
Is
is
there
just
any
as bad.
benefit to
Which
not
is-
having it if you
It's just
are using
easier
the
for
proper
assembly.
Does it make
But
it
the
quicker?
bottom part, the bad part about that is if somebody's getting that complacent, then the whole thing's relying on the electrical connection for its strain relief, and
That's a big no-no.
that violates the whole safety of the whole cord cap.
If I could, real quick, where do you guys get your pigtails from? And when I say where, how do you?
I don't
make
buy any manufactured pigtails. We make if we need any pigtails on our job site, we make them on our job site.
Okay, and those come from temporary power cords. Is that correct? Like a longer temporary power
Well, a
cord.
pigtail is a temporary power cord. You don't put anything like this in for permanent.
Right, I understand.
Permanent practice.
But from what I've heard from the depositions of other electricians, generally pigtails come from where you have a longer temporary power cord that may be damaged, like on one end, or in some way rendered not useful as a long power cord, and then they go and they cut
Well,
the cord and make it
a
shorter.
pigtail's usually at a point to just pick up, rather than taking your pre-made 200-foot cables with these male and female connectors on them. You provide a pigtail from your power source, which is from the breaker to a female point of connection.
So you don't need all that
That's
extra
what a
line.
pigtail basically is. A pigtail is just a short
Temporary power cord.
temporary power cord, which provides a point of connection for a longer run of use.
So what I'm asking is, you say you make them whenever you need them. Do you make them from longer temporary power cords? I mean, obviously you don't buy
Yeah,
a really short cord.
I've made extension cords where I take a 150 or 200 foot cable with an end on it and go right to the breaker panel.
Have you ever in the past had a 100-foot cord that's damaged on one end? You just cut off the damaged portion and use a good portion as a pigtail or even as a shorter
Yeah,
power cord?
if a
Cut and
cable gets
splice.
damaged, if it gets damaged, let's say a 200 footer gets damaged in the middle,
Mhm.
you'll cut it, put another male-female connector on the end, and now you have two 100-foot cables.
You just cut
And
out the damaged
you cut
area.
out the damaged
Well,
part.
that's a standard, everybody does that.
Well, it's just good use of your
Materials.
materials, because this stuff's very expensive,
Uh-huh.
and you want to utilize it and keep it in good condition as you can. But other trades, and I'm not even saying even in the electrical trade, a lot of this stuff goes through a lot of physical abuse
Mhm.
on a job site.
Is there a point where you can visually tell, hey, this has been through too much?
Yeah, what
Replace
happens?
it?
The outer jacket gets ruffled or pulled or twisted, and it looks abnormal on a.
So that's
on a-
another thing that might have been wrong if we'd had a chance to look at the cord.
Yeah,
The outer might have been
something is
ruffled.
wrong if they didn't allow you to investigate the pigtail. Something is wrong there to begin with.
Is there a way you can tell whether the end cap has been too abused? I mean, on a visual basis, can you see like scarrings or if it's dented, would you replace it?
It would, if you could get access to that, to the,
We do have access to the actual end cap involved in the accident. It has burn marks and things of that nature.
I might be able to look at that and tell which conductor went to ground or which conductor went to fault.
And that would give us a source of how the accident actually occurred, wouldn't it?
It may give an indication. I wouldn't be able to tell if they had a bigger cord in there or not, but I'd be able to tell what occurred in the cord cap possibly.
Okay.
That's what
Okay,
I'm
I
saying,
have
that's what I'm
further
saying, either the ground came undone, something came undone inside the thing when he went and twisted it, or he twisted the conductors together via the collets being missing. I mean, I can almost see that it's happened because I've seen it happen before.
You have. And now, you've seen it happen before?
I've
because
seen
of
it happen
collets?
before, but nobody got injured.
I see.
I've just seen reasons why things
And
happen.
they didn't get injured probably because there was electricians.
Well, it just becomes busted over use over time and abuse.
Okay.
Things just come apart, things aren't checked. And usually, like I say, it's just good practice to maintain and keep the integrity of your system, or if a contractor's building this building, you want probably to hire that contractor to maintain the integrity of the temporary power system as it's going on, because you don't want you don't want to just let anybody be handling that because of the liability.
I have one question on unions. You had mentioned that you're a member of a union, and in our situation, the people doing the asbestos removal did have an electrician. However,
He doesn't have to be union or non-union
He
to
was
be
non-
qualified.
he was non-union. But my question is, if you were in that situation, you were the electrical supplier, the contractor, would you have? He was kicked off. He was not allowed on the premises because he was non-union. Is that typical of would you have not allowed another subcontractor that had non-union to be
On
in
my
the-
particular job site, I police it for any other electrical contractor coming in.
So you wouldn't let anybody in, you want complete control of it.
You only want that because if it becomes a point where you have a lot of other contractors coming in, then, I mean, you don't have any point of responsibility. Then the responsibility lies with an individual job, and it really gets broken up. It's hard to keep integrity of a job site if you have a bunch of different people coming in handling
you want to
different
be
things.
solely responsible, and you don't want anybody else
Well,
to mess
I,
with what
I
you're
only
doing.
feel that way because I'm basically foreman of a pretty large Rockwell facility. And I wouldn't want other contractors coming in, mainly because there's really no reason. I mean, we can handle everything, but you get into a point where, okay, now you're having a mechanic that you trust, and then all of a sudden somebody else is coming to work on your engine that you don't want.
But I assume if you're going to kick somebody out, you're going to make darn sure their electricity is good.
Yeah, I couldn't be as blatant as to just kick somebody off. Sometimes I have to swallow my pride, and yes, I did have to work with another contractor on site. It just said the job was of magnitude where, hey, they're all out of the same local. They're perfectly competent electricians, and I had no problem with them. But it's just that they were on one side working on a specific project, which is fine, and sometimes it aggravates employees working for you and whatever, but that's just more like personalities. You just have to deal with it. It's not that anybody's better or anybody's worse. You just have a point that, hey, I'm responsible for a certain number of things, and if I let other people coming in, then all of a sudden you feel like you're losing what you're responsible for. And then that kind of have a tendency to maybe let you get a little complacent. Oh, well, that was that other guy's problem, you know. You don't want to get into that. Safety's basically first. I had an opportunity to work with the other contractor, and everything worked out quite well. I mean, if he needed something, I obliged him.
Okay, so there's no standard where
No.
people doing asbestos removal would have their own electrician normally or something.
That would be perfectly okay. If that person's going to a lot of asbestos job sites, it's probably safer that he does have a qualified electrician going with him. The electrician can do the connection, and it might be able to assist him in some of the other work. Or he's a person that maybe not be just an electrician, but he's at least qualified and is knowledgeable enough to maybe do a panel hookup, or
Okay. Do you have any other questions? I think we're set then.
yeah.
Good job, Marcy. What day is today, Marcy?
Halloween. And I am gonna go trick-or-treating!
How old are you?
7, Dad, where's Kaylee?
It's Halloween 1993. We're very, very impatient for Kaylee, and we're going to go out and look for her right now.
Yeah!
Do it again. Good job, Abra. Go, Katie, come on.
Come on, Lizzie!
After it. Come on, get it, Candace. Here it comes. There you go. Kick it hard, Candace. Give it a hard kick. There, perfect. Go, Caitlin. Good job, Caitlin. Good job. Let's go. Here's the scoring monsters. Come on. Stop it. Let's go. Don't fight each other for the ball, Marcy and James. Good job, Abra. Go. Good job, Candace. Way to get a good kick in there.
Hey, Sarah, you're on the wrong side. Get it, Cassie. Sarah, you're on the wrong side. Get on it, Caitlin. Caitlin, chase it. Get it out of the field. Go, Cassie. Good one. Chase it, Casey. Cassie.
Stay in your positions, girls.
Okay. Good try, Caitlin. Keep the ball. Back a little bit. Okay, Cassie, it's all yours.
Come on.
Get it across the field. This way.
Come on, Sarah. Stay with us, Sarah. Don't back off. Stay with it.
Come on, Mars.
All the way up the side, Sarah. Big kick now. Good job. Go, Caitlin. Look out. Get out of the way. Let's go. Come on, Dolphins. Move up in the ball. Move up. Come on, Alyssa. Get the ball, Alyssa. There you go, Alyssa. Stay with it, Alyssa. Let's get the ball outside now. Move it out to the right side of the field. We got a lot of room. Good job, Cassie. Let's go. Come on, Jamie. Chase it down. Chase it down. Just keep running right into the ball. Jamie, Lindsay, let's get in the court here. Come on, back up.
Field.
The field, whatever game I'm playing. Basketball's at 11 o'clock.
Oh, you have practice, that's right.
Yeah.
This is November 13th, 1993. This is Marcy's last soccer game of the regular season. She is 7 years old, and she is number 4.
Come on, girls!
Good friends Kaylee and Jamie are on the same team here in Irvine.
Katie, go towards the goal! Jamie, go
And that's the exciting video that you're watching now.
Let's go, let's go!
I see Marcy coming down there.
Big kick, Kelly. Come on, Tiff! Come on, Sarah. Take it up the field.
We're near their goal.
Sarah.
He's right there.
Hey, stay with it, girls. Stay with it. Good going, Candace. Get on it.
Sarah, get up there.
There's Kaylee.
Good job, Kaylee.
Sarah, stop
Run
fighting.
up with the ball, guys.
Mars,
Forward. Don't
go.
Blue throw in. You got to get the ball. Sarah, go ahead and throw it in.
Be tough.
Throw it out that way. Go out, Candace.
get
Go
ready.
Out. Go
Get
out
ready.
and follow the ball. Go out and follow the ball.
There she is.
Go get it. Let's go. Come on, Jane. Let's go. Let's go. Let's go. Let's
Jamie's
go.
going in for a goal.
Good. That was a good play, Jane. Come back and get it again.
Good kick, Abra.
That was good. Be quick. Just like that all the time,
Stay
Jamie.
with it, Abra. Pursue, sweetheart. Go up there and pursue.
Let's go. Come on, Mars.
Good job, Alyssa.
Stay with it. Good, good. They'll spread out.
And here we have a spectator for today's game. Say hi, Matt.
Let's go. Be aggressive.
He'll
Get
say
it.
hi.
Get it.
Hi.
Kick, Abra. Come on, Marcy.
Matthew's in
Come on, Marcy.
between 8 or 9 girlfriends right now.
Don't fight with each other for the ball,
And he
girls.
wants to smile right now.
Come on, Candace. That's your ball.
Matthew
Go
is in the
get it.
6th grade here
Okay, go ahead,
at
Kaylee.
Meadow Park Elementary.
Walk, just go hard. Keep your back foot down. Good throw.
Go, Kelly.
You've got a purple ball. It's purple ball.
Go, Marcy.
Come on, Sarah. Go down that way, girls. Throw it all the way over there. Candace,
Go,
go
Mars.
towards that way. Watch your feet on the line. Get it, Alyssa. Stay with her, Alyssa.
Get in there.
Good job, Candace.
I know,
Get it,
Michael.
Alyssa.
Way to stay with it, Jane. Run down the center of the field, Jane.
All right, Cass. Right there.
Big kick.
Go, Cal. Good job, Kelly. Good job, Kelly. Good job, Kaylee.
Kick it in now. Go again. Go again. Stay with it next time, hon. Good job.
Go, Mars.
March throw it in.
This is going to be the greatest throw in the history of soccer right now.
Go, 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 go. Go on, go. Go, 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 Jamie. Where you at? Okay, go, Mars, Mars. Go in. Keep your back foot down on the ground. Go right for center. Good shot. Go. Get right there. Go in. Back foot down on the ground. Where is it? Play defense, Kelly. Play defense, girls. Hey, think upfield for a break. All right, Cassie. Cassie, take it this way. Good, good, good. Go.
Get in there. Get in there. Kick it.
There you go, Sarah. Big kick. Good job, Caitlin. Go. Come on, Dolphins. Go, good job, Alyssa. Go, Caitlin.
That's the end of period 1 with the score 0-0. Marcy, what do you think so far? Mars,
No one gets tired.
tough game?
Hey, quick drink of water. Jamie here.
Stephanie, you like playing the goalie? You want to play one more quarter?
Okay, everybody play this exactly the same positions this quarter, okay?
Okay.
Exactly the same. Lindsay, you're a scoring monster, okay? Just get real up close to the goal where they are, and when the ball comes to you, let's go. Where's the rest of the team?
I don't know.
Okay, now continue to be aggressive, Jamie, okay? Let's stay with the same positions. Everybody feel okay?
Yeah.
How we doing? Can we beat this team? Okay, let's go. Let's get a goal before the halftime, okay? Come on, girl. Keep your back
Kelly,
on the ground.
get back, little boy.
What a kick. Did you see that throw in?
Go, good. Go, good.
Bullets were dodged.
You know, I
Here
just
they
thought the
come,
ball-
raisins. Yay, raisins. Raisins, cheer.
Alyssa,
Good
good work.
job, girls. Okay, we're doing
Marcy.
great out here. All right, raisins. Should we go?
Come here. Little halftime talk. Oh. Great game,
Well, I'll
girls.
tell you what I'm going to do, though. Very aggressive center defense monster. I'm going to let you come, Katie, I'm going to let you come all the way up to the center of the field, okay? I'm going to let you come all the way up to the center of the field. Kaylee, I want you to be center half monster. Okay, you can come up, and if you can use that big foot and kick a goal, that's fine. Lauren, I want you to switch with your sister, Allison. You're going to be playing a defense monster along with Katie, okay? Everybody, now listen, girls. Yes, but listen to me. Listen, girls. When we kick the ball once, and we can kick it again, we got to go after it a second time. That's what's going to make the difference in this game.
You okay, honey?
Okay. Kelly.
All right, Jamie.
All right.
Good recovery, honey. Go get him, Jamie.
Good job, James.
Let's go, girls. Win this for Jamie.
Jamie, that was a great stop. Do it again.
Oh, God. I get...
Still in.
Remy, mistake,
I got it.
We've been one short this whole game.
I got
Okay?
it.
Good.
We've been one short this whole game and we're still hanging. Jamie, how's your heart? Marcy, how's your tiredness? God. Kayla, you know how close you came to a goal? This time get it in, okay?
Okay.
All right.
All right. We've been working for this quarter all season long.
girls.
We're going to make a statement right now. We're going to go in there and play really hard as we can, because we don't have to worry about soccer until next year.
Yes.
Play as hard as you can, and then you can throw a temper tantrum this afternoon for your parents, okay?
Pretend
All
they're
right,
SC.
let's do it. Okay?
Good job.
Okay, let's go. Same position.
Let's go. No,
Same position.
blah, 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 blah.
Tiffany, you did a great job. Very nice. Kaylee, great. Good play. Fantastic.
Good game, Mars.
Way to go, Allison and Lauren.
You girls
Stephanie, you
gave
did
it all
wonderful.
you had.
Lindsay, I can't believe how well you did. Okay.
Way to go, girls.
Okay, girls, what's the name of this team?
Dolphins.
Blue Dolphins, okay.
No, just called the Dolphins.
Up the alley and down the street, who's the hardest team to beat? The Blue Dolphins. Ready? One,
Just called
two.
the Dolphins.
Okay, Dolphins. Up the alley.
Down the street. Who's the hardest team to beat?
The
Dolphins.
Let's line up, girls. That was a great game.
Game, Mars. Good
Okay,
game,
you
everyone.
did a wonderful job back there. You really did. The referees too, girls.
What, honey?
This house, what's tomorrow game? Notre Dame, Florida State game?
Sure, then you're not going to UCLA again?
Why?
You're leaving in 20 minutes.
Are you pick something there?
No.
Why not?
I'll pick you up there in 20 minutes.
Beautiful game. Great game.
You videotaped?
It's Irvine versus Fountain Valley in the semifinals of the Slam and Jam Championship. And here the team comes, ready to go. Go get them, guys. Look at Eric's face. Nice smile.
Game face.
There's the game face. Good, Jeff. You play Fountain Valley, and there's the brain trust. It'll be a big game today. Good luck, coaches.
Thanks. Bye, Jordan.
There they are, folks. The Irvine Bulls. This is November 27th, 1993. The Irvine Bulls, my goals. 8th grade on that team. There's Michael Wallace, 8th grader. Washington White, 1 second.
Come on, guys.
Justin.
Wait, Simon, get up. Get up. Come on.
Yeah.
Come on, Vic. Come on, Vic. Switch.
It's there. And they're getting ready for the big game against Fountain Valley. Fred's here. Jordan Roper.
Pick it up.
Eric Farmerhead. Oh wow, I know. I don't think they're very well coached, the other team. Exactly.
You may have to move it. Run back. Jeff, pull your bags up.
Where you going, Simon? Where you going?
Okay, Mike. Take it away. Deny.
Ronnie, good job, Jeff.
Deny.
Defense, block up, Jeff.
Let's do it. Right.
Come on, print that guy!
See, guys, keep it up, help.
Run him!
Defense.
All right. Greg got a, you got some help? She asked me to help
I can't say anything. It's gonna be on film. Susie.
All right. Oh, Michael.
Yes!
Who's got 15?
Great try, guys.
Come on, Simon!
Deny the ball.
Right.
That's it, Jeff Green!
Right.
Deny.
Help!
Great.
Sit, Jeff.
Turn around.
Mike, Jeff, right down for the hit. It's good.
The guys are
I mean, you got to be tough under that basket. So if you're not just Oh, no. Yeah, nice shot.
Very intelligent. Thought that one. Yes.
All right. Woo. Out. That's it. That's it.
Good job!
No. Jump it. Jump it. That's it.
Jeff Green, good job!
And Simon. No, wait. Justin.
Come on, Jordan, better defense!
D. Jeff.
Again, white ball.
White. One. Who's 33? I just heard him say it. Maybe he said 3.
Come on, get back,
Hey, jump.
Woo! Go, 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 go. Box out! Get down there. Michael. Oh, God.
Strong, keep it strong.
Have some more. Want some more? Sure.
Go, back.
3,000. I'll go for that. So I'm out there 1 miles a day from now to 10 hours. Walk from here to Pasadena or something. If you want to stay in Orange County, here to Dana Point.
Deny, back.
Enjoy. If you want, this ketchup might be messy. If you want ketchup. I'm sure we'll need that.
Deny back. Deny back.
Get through. All over you. Deny that, Simon.
No, I think.
All right. Here. All right-handed. Nice job, Fred. Way to draft. That's where the draft's got to be.
Great defense. All right. Help! Oh, Simon, you got 2. Jump! Mike! There you go! Aggressive D, denial. Get low. Good D. Oh, my. Jump! Yeah. Ball is there.
Move.
Nice. Up.
Good job, Simon. Good hustle, buddy.
They got a hamburger here? They bought a hamburger here?
Gotta jump, Simon. Gotta jump.
It's not over.
Go. He's all right. He's all right. He's dribble left. Come on, keep it.
Foul on Matt.
Oh!
Right, 34. Come on, son.
Dribble! Behind. The high post. The high post. Come on. Pressure. Forward.
Look!
You didn't want to get any blood out, huh?
Yes. All right.
Yeah. Deny, Justin. Stay in front of him, Justin. Oh, he's carrying the ball. Come on, get him. All over him. Come on, he's boxing out.
Gee. Come on, get a hand up.
Push, come on. Swing it. Move.
No!
up, guys.
Foul on Jordan. Come on, guys.
Control, control. Control now, control. Control.
Last shot, guys.
Make him, Jeff. Steal it and go. Pick it. It's our ball. Our ball. There we go.
Left, let's go. Good job, Simon.
Look. Beautiful play.
Tonight. Don't let him up the court, Mike. Don't let him up the court, Mike. Simon. Don't let him up the court.
He's all right-handed, Mike.
Step up, Jeff Green.
All right. Okay, stop. Pass off. Watch the line.
Go through, Mike.
No baseline, Simon. No
Deny
baseline.
the ball.
Get open, guys. All right.
Oh. Deny. Deny the ball. Here it comes. Go, look.
Don't force it. Middle floor. Middle.
Nice.
All right. Help.
How about? Short.
Beat him. Cut, my. There's Fred. Layup. Beautiful. Oh. He makes that shot if he doesn't do that loop.
Hey, Eric. Perfect. Great execution.
Right? Yeah. Pick it, Fred. Oh. Come on, grab it.
Same team. All over.
Yes, look. Oh. God.
Get on the floor.
Oh, there it is. Please make it. Yes. Go.
Shoot, Simon. Come on. Man.
Look to the post.
Take him. Nice, Eric.
Simon, the roll was there, but
Come on, see some offense now. Jeff Green, way to be offensive. That's the way to do. That's all right. That's what we need out of you.
Help, get the ball. Don't let him get it back, Mike. Don't let him get it back. Don't let him back. Don't let him.
Help!
Long. What that? Look. Oh, all right. Woo! He's unbelievable. Is he unbelievable or give me a break?
Help!
No. Yes! Beautiful, Eric.
Help!
My sure has another tape. Get it for me. Yes, she does.
Dude! Come on!
Great play, Mike. Oh. Oh, nice shot, Fred.
Number 3, Vic!
All right! Oh.
Good hustle, Matt!
Defense, guys. Tight. Tight. Deny. Winner of the next game. Jump! Oh. Go. Stop ball! Stop ball! Look. A little short.
Make it.
I think it's ARC and KD. Yeah. It's not our game, guys. It's not our game. Played good today, coach. That hustle, like really good defense. Still no intensity though. No emotion. I don't know what to do about that. Way to box out.
Take it.
Nice, nice.
Nice job, Vic.
Steal it. Steal it. Steal it.
John.
The way they look is
See, it's a shit.
28 seconds, guys.
Go back.
take it back.
Swish. Look. Look.
What a pass.
Yeah. Nice. Yeah. Assist, Brad.
Calling. Only halftime.
They already played the second half.
It is? Cool.